So for question number 1, we are going over the top of a vertical circle. Okay, so this is our situation here. If we lose contact with the road, then are we exerting any force on the road? Then what is the road not doing to us? Pushing back. So what's the normal force in this question? 0. Okay, and that's the first thing you have to realize in order to do this question, okay, is that Fn is going to be 0. All right, so if they have a diagram or they've got some givens here, we were told the mass, we were told the speed, okay, and we were told we're looking for the radius. So give them a mark for some givens there. Okay, Fc equals forces in minus forces out, which in this case means that Fc equals just the force of gravity, because that is the only thing acting here. Okay, so give them a mark if they've got something like that. Okay, and then we have mv squared over r equals m times g. Okay, we are looking for r. Okay, so we're going to bring r over to this side here. Okay, and then we are going to bring m and g over to this side. M will cancel. Okay, and we'll be left with v squared over g equals r. So give them a mark if they have this manipulation. Okay. What are we up to there? Is that 4? Yeah. Okay. So when our numbers are plugged in, that will be 32 squared divided, by 9.81. And answer here. All right, is 104 meters for our radius. Now, I think we only have 2 significant figures, is that right? So it's just going to be 1.0 times 10 to the 2 meters for their 5th and final mark. All right, questions there? Okay, question number 2 then. So on question number 2, okay, our givens are that we know the mass of the fighter pilot, 75 kilograms. Okay, we know that the plane is traveling at 300 meters per second. Okay, and we are told that it's the bottom of a vertical circle. Okay, so our plane is doing this, and the pilot feels a force, a g-force of 8.5 g's while traveling at this 300 meters per second. So how much heavier than normal does he feel? 8.5 times heavier than normal. Okay, so it's important for us to realize that our normal force is 8.5 times the force of gravity. That's what 8.5 G's means. We talked about that the other day when we said they feel twice as heavy as normal, they feel 3 times heavy as normal. Okay, we did a couple examples like that the other day. All right, so we have normal force acting in, we have gravity acting out in this situation. So mark for givens here. Forces in minus forces out. Okay, so that's going to mean that Fc will equal normal force minus the force of gravity. Give them a mark for that. Okay, so that means then that Fc equals 8.5 mg minus mg. Third mark. Okay, they had to realize that in order to get this whole thing done. All right, what's 8.5 mg minus mg? 7.5 mg. Okay, so mv squared over r equals 7.5 times mg. All right, I'm looking for the radius of the circle again, so I'm going to bring r over here just like I did the last time. Okay, and then I'm going to divide both sides by 7.5 mg. The m's will cancel. Okay, and I'll be left with v squared over 7.5 g equals r. So 300 squared divided by 7.5 times 9.81 equals r. So give them a mark for this. That'll be their 4th mark. Okay, and then we'll give them that. So either the manipulation or the number plugging is their 4th mark. And we have 300 squared divided by 7.5 times 9.81. All right, so the radius of this circle is, and we have how many significant figures here? 2. So 1.2 times 10 to the 3 meters. 5th and final mark. So give them a mark out of 10. Let them see it, and then in a nice neat pile on this desk here, please. I think they were both out of 5, weren't they?